In this video, we will study what is servo system and its classification. The content which we are going to cover is what is time varying and time invariant system, basics of servo system, AC and DC servo system, significance of the Laplace transform. The learning objectives which will be attained are: student will be able to classify the time varying and time invariant system, understand the basics of servo system, understand the mechanism behind the DC servo system. So time varying and time invariant system. Time invariant system is a system whose response varies with respect to the time. Means if we feed input to certain system, then its output response is varying with respect to the time, then such system is said to be a time invariant system. Time invariant system. Time invariant system is the system whose response to an input signal does not change with respect to the time, then such system is termed as the time invariant system. Examples: consider the cases of bicycle and a rocket. Here in the case of bicycle, the model of bicycle does not change much over the time, means it almost shows no change during a ride. The air filled in the tire of the bicycle does not change much over the time, and this is an example of time invariant control system. For time invariant system, consider the model of rocket. A tremendous amount of fuel is burned when the mass reduces quickly over the short period of time, and thus this is an example of time varying system. So what is servo system? Servo system is defined as an automatic feedback control system working on the error signal, giving output as mechanical position, velocity, acceleration. In other words, servo system is one of the type of feedback control system in which control variable is mechanical load position and its time derivatives are like velocity, acceleration. The figure shows the basic block diagram of a servo system, which consists of input followed by the error detector, servo amplifier, servo motor, load, and output, which is again fed back to the input side by the means of feedback element. Here we will study the operation of servo system. Here error detector basically has the two inputs, one is reference input and another is feedback element input. Here the error detector is basically a potentiometer which will act as a error detector, which will be having one of the reference input and another is your actual load position input. The error between the two positions is given to the servo amplifier, which will amplify the error to certain extent. Then the output of the servo amplifier will be given to the DC motor or servo motor in order to produce an output which is given to the load in order to change the position of the load. In this way, the servo system operation will take place. Difference between AC and DC servo system. Here in AC servo system, the efficiency is low, whereas in DC servo system efficiency is high. In AC servo system, here we are having a low power output, whereas in DC servo system we are having a high power output. AC servo system requires less maintenance, whereas DC servo system requires frequent maintenance. AC servo system has the less stability problems, whereas the DC servo system has the more stability problems. AC servo system shows or provides smooth operation, whereas DC servo system shows or provides the noisy operation. AC servo system has non-linear characteristics and here the DC servo system is also having the nonlinear characteristics. So DC servo system, this is the general block diagram of a DC servo system. The operation of the DC servo system is similar to the previous one servo system, except here we are giving a DC signal. Here the DC servo system consists of a potentiometer as an error detector, DC amplifier, DC motor, DC gear system and DC load whose position is to be changed. Here the potentiometer has the two input, which one is the reference input and another one is actual load position. Here the error between the two positions is given to the DC amplifier, which will amplify the error signal. This error signal will be given to the DC motor, and this DC motor will provide an output which will finally decide what position needs to be changed for the load, means how much amount of change will be there in the position of the DC load. In this way the DC servo system operation will takes place. Here you can see the working of DC servo system operation. Laplace transform. So why there is a need of Laplace transform in the control system? Here the Laplace transform is used to evaluate the performance of an automatic control system. Commonly used mathematical tool for this purpose is a Laplace transform. Here the Laplace transform basically converts the differential equation into an algebraic equation in the form of S. Laplace transform exists for almost all the signals of the practical interest in the control system. Here the solution of integral differential equation of time systems can be easily obtained by the means of Laplace transform. Laplace transform provides an easy and effective solution of the many problems arising in an automatic control system. Laplace transform allows the use of graphical techniques for predicting the system performance. For summary, so in this video we have seen what is time varying and time invariant system, principle of servo system, block diagram of DC servo system and use of Laplace transform. Thank you.